Assalamualaikum and hi everyone. Today we will present about our assignment, which is application of RLC circuit. RLC circuit are using in metal detector, so we choose the metal detector for application RLC. Okay, this is our member group. What is metal detector? Metal detector is device that is capable of detecting metal elements on a surface. Nowadays, there are many public places such as hotel, shopping mall, railways, and airport are using this device to detect metallic objects such as gun, knife, and bomb to prevent the occurrence of a criminal case. There are different types of metal detector, which is handheld metal detector, walk-through metal detector, and ground search metal detector. This is walk-through metal detector. We can see it at the airport and also the handheld metal detector. For the ground search metal detector, we are used to find the metal under the ground. This is our circuit diagram. We use 555 timer, capacitor, resistor, inductor, and the speaker for the output. Okay, how metal detector working? There are inductor in RLC circuit, which is this inductor will detect the presence of the metallic object. The inductance in the inductor will increase, so this will increase the flow of current and capacitor start charging quickly and feeding the trigger pin of the IC 555 timer. This will change the change of output oscillation frequency in IC 555 timer goes to the buzzer, and buzzer will produce a sound. So that's all for introduction.
Hi, Assalamualaikum. My name is Nina Fanti Misabudi. I am from BEEE section 1/1. So today I would like to construct a circuit which is metal detector using Proteus. I am going to show you how to construct the circuit using a Proteus. First, you can just select the component mode here and click P to pick the component. You can just type the keyword here. Okay, so I already picked my component. This is the component that I am going to use to construct our circuit today. So first I am going to put battery here, 55 timer. Okay, pin is connected. The pin 8 is connected to pin 4 and will be connected to the positive pin of the battery. As for the ground, we will be connected to the negative pin of the battery. Then trigger. The pin trigger will be connected to pin threshold of the 55 timer. I'm going to use capacitor here. Okay, connect the capacitor here. I am going to change the value of the capacitor to 2.2 microfarad. Okay, then I'm going to use another capacitor here. The capacitor, oops, the polarity of the capacitor, I forgot to change the polarity. I'm going going to change it now. Okay, so here I'm going to add the inductor here. The value of the inductor will be changed to 150 millihertz. So I am going to insert capacitor. The capacitor will be connected to pin 6. The value of the capacitor will be changed to 47 kilo. As for the output pin, I am going to add another capacitor here. Okay, the value is 10 micro. Connect here. Okay, so I'm going to use the output, pick the output. Oh, I will choose buzzer. I'm going to use buzzer here. So okay, so I already finished constructing my circuit, and click at the buzzer. First you have to check the operating voltage of the buzzer. We are using only 9 volt supply, so the operating voltage must not exceed 9 volt. So I'm going to change here. I'm going to use 2.2 volt. Okay, then click run. Okay, simulation is not running in real time due to excessive CPU load. Okay, if this occurs, you have to check the circuit again. 10 microfarad, 150. Oh, the value of the capacitor here I forgot to change. I'm going to use 2.2 micro. Run the circuit again. Okay, I forgot to put the grounding. Oh no. There is no error here, so you can just proceed. So the function of the metal detector is based upon the principle of electromagnetic induction. Metal detector contain one or more inductor coils that are used to interact with metallic element on the ground. So in this circuit, I just use one inductor. So the value of inductor can be changed to get the different sound of the output. I am this is when I use the 200 millihertz inductor. So I'm going to change again to 150, the original value. in this circuit, the inductor is used as a trigger to generate the output of the buzzer. So when we test the functionality of the circuit, we are going to check the current and voltage here. And first we are going to check the voltage to obtain the voltage at RLC circuit. So I am going to use multimeter. Okay, here we got voltmeter. Okay, so for your information, and I am going to measure here because we are going to obtain the RLC circuit, and as you can see, the R is parallel with capacitor and inductor. So this means the voltage at R equal to the voltage at C and L. So I am going to simulate the circuit to obtain the voltage. Okay, as you can see here, this is the voltage that we are going to obtain, 18.7. So I am going to split the circuit and build a new one with only using this component and power supply. So this is the circuit that I obtained, the circuit that have all the component of RLC. Okay, so I'm going to change the voltage here to 18.7. Okay, as you can see, when switch is here, we can obtain V node and I node. When switch is moved to here, we can obtain the alpha and omega node of the circuit. And alpha and omega node will be calculated and using the calculation with the formula of the second order series RLC. Okay, first we are going to obtain the current here. As you can see, the current here can be measured series with the component. Okay, I'm going to delete the wire here and use the emitter. Okay, I am going to change the display range to milliampere. So when I simulate, I got the current equal to 0.4, or if you are using the calculation, and the current will be 0.3 something. Then if you want to calculate the voltage, okay, as for the voltage, you can use the VIR, Ohm's law, V equal to IR. As for the current, we got 0.4, and the resistor is 47K, so you can just calculate it, or you can just use voltmeter, connect the circuit. The voltage can be measured parallel with the resistor. Voltage voltmeter. Okay. Put it here and connect it here. Okay, so this is the voltage. Okay, as for the voltage, and it's 18.7 as it's only have one resistor, and all the voltage here equal to 18.7. Okay, so when the switch is here, we can calculate the alpha and omega node using the calculation of the RLC second order circuit series. Okay, so this is the series. First, we are going to calculate the alpha and omega node. Okay, wait. I'm going to show you. Okay, as for series RLC circuit, the alpha equal to R divided by 2L and omega naught equal to 1 per LC square root. Okay, so that's all for the simulation.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Hanania binti Marhalim, and I would like to explain about analysis and calculation result based on our circuit, which is metal detector circuit. So this is our overall circuit, and this is the RLC circuit that I will calculate. So here we have one supply with 18.7 volt, one resistor 47 kilo ohm, one inductor 150 millihenry, and one capacitor 2.2 microfarad. So from this circuit, I have separated it into two conditions. First, when t smaller than 0, we have only one voltage source and we have one resistor. When t bigger than 0, we have RLC circuit that contains resistor, capacitor, and inductor. So firstly, when the condition of t is smaller than 0, the switch is closed for a long time. The capacitor behaves like an open circuit while the inductor acts like a short circuit. The initial current through the inductor is V0 equal to 18.7 volt. This is because our circuit only contains one supply and one resistor. For I0, we can get the answer by using Ohm's law, which is V0 over R. So the value of I0 here is 0.4 milliampere. Okay, when the condition T is bigger than 0, the switch is open. What remains in the series RLC circuit without the voltage source? The characteristic roots are determined as follows. So here we have to calculate the value of alpha and the value of omega naught. So the value of alpha we can get from the given formula R over 2L. Also same with omega naught, we use the formula 1 over RLC. Okay, when we get the answer, the value of alpha is bigger than omega naught. So we can see that it is the overdamped case. So we have to use overdamped formula to get the value of S1 and 2. So when we calculate using the formula, we enter the value. So we got the I total is A1 exponent S1t plus A2 exponent S2t. Okay, next. Okay, we have to calculate the value of A1 and the value of A2. So we use situation 1 to get value of A1. Okay, so we only have to use the formula, and finally we got the answer. A1 is equal to negative A2. So for situation 2, we want to calculate the value of I total. So we also use the formula. Okay, here we got the final answer, negative 0.8 kilo exponent negative 10t plus 0.8 kilo exponent negative 313.3 kilo t. Okay, the calculation is finished, and here is the overdamped graph. Okay, we can see that it is the value of IT versus time. So it is the graph. Thank you.
Hi sir, my name is Anandini Vijayan. Today I am going to do discussion based on metal detector by using IC55. These are the circuit metal detector by using IC55. The IC55 is a monostable. Monostable is a characteristic by giving high output when there is a low pass signal to the input trigger pin. The duty cycle of the output plus from IC55 to the inductor L1 then capacitor C1 which is connected in series to the trigger pin of IC55. Here the inductor when we use a hair cord, when the current flow touch the inductance, magnet fields to the current flow develop around it. This magnet field since when a metal is both near the inductor, its inductance increase. This results in increase in flow of the current and capacitors start charging quickly. When the capacitor charge quickly, the voltage will be automatically increased until 18.7. The voltage our input given is 9 volt, but when the capacitor charging, the voltage will be increased quickly. This also band fast filter circuit. From this, we can get a second order RCL series. Based on this, I am going to show calculations. When t less than 0, we can identify V naught and I naught. First of all, we should capacitor open circuit and inductor will be short circuit. And also when V higher than 0, we can identify alpha and WO. So from this we can get overdamped case. That's all, sir. Thank you. Conclusions based on metal detector by using IC55. In the conclusion, a metal detector is used to identify some land method in the area. A metal detector is an electronic device used in many places, such as a movie theater, shopping malls, hotels, and public places to detect any metal object keep hidden inside a bag or person who a bad intent. We also need to understand the concept of RCL circuit. Here in the metal detector circuit, we used IC55 timer and inductor to detect metal and warn the community by means the object hidden. This metal detector project can be powered from DC voltage supplies of between 60 volts until 12 volts. If a metal flows through the inductor, the frequency of the output will be changed and the 8 ohm speaker will be noise. That's all, sir.